So that's the end of the exposition for defining the trig functions, figuring out the values of different trig functions. The rest of this section is about, we get some of our first trig identities. Now, an identity is a formula that's always true for any input that's in the domain of the functions involved, okay? So that's called an identity. So we have a large number of trig identities, of which we'll learn a subset, but it still might seem, it's still a fair number because there's 6 different trig functions, right? So first of all, definition, 2 angles are complementary if their measures add to pi over 2 or 90 degrees. What this means is that they're angles of the same right triangle, interior angles of a right triangle, right? Because the interior angles of a flat triangle add up to 180 degrees. A right triangle, one of the angles is 90. That leaves 90 degrees more, and that's split up between the other 2 angles of the triangle. So that's where complementary comes from. Okay, so their measures add up to pi over 2. When complementary angles are acute, because they don't have to be acute, but when they are, then they're the interior, that's what I meant to say, then they're the interior angles of a right triangle, right? So alpha and x in my diagram here are complementary angles. Right? They don't have to be acute. Like you could have pi over 4 plus 2 pi or something, and then have pi over 4 minus 2 pi, and those would add up to pi over 2, right? But this is how we usually visualize them, and it's the most common angles that we use are acute angles for these. But it doesn't actually matter, and that's important for what we're going to do. So the complementary means alpha plus x, that's my 2 interior angles other than the right angle. Alpha plus x equals pi over 2. So I just solved for alpha from that equation. So alpha equals pi over 2 minus x. So the opposite of angle alpha, notice in the triangle, the opposite of angle alpha is the same as the adjacent of angle x, right? And the opposite of angle x is the same as the adjacent of angle alpha, right? So that means that cosine of x equals sine of alpha. Right, because you're just switching the opposite and adjacent, which is, from the definition of sine and cosine in triangles for acute angles. That's the difference, is the cosine you use the adjacent, and the adjacent over hypotenuse. Sine is, adjacent over hypotenuse. Sine is opposite over hypotenuse. So cosine of alpha is the same as, cosine of x is the same as sine alpha. And also sine of x is the same as the cosine of alpha. And so from this we get our first set of identities. So that means that cosine of x equals sine of pi over 2 minus x. I just substituted this pi over 2 minus x for alpha is all I did. Right? So if x is one angle, pi over 2 minus x is its complement. Okay, so cosine of x equals sine of the complement of x, is all that's saying, really. And sine x is the cosine of, same thing, pi over 2 minus x. And since all the other trig functions are made up out of cosine and sine, the same is true for all the other 4 trig functions. So these are identities. They hold for all trig functions. So tangent of x equals, what would it be? Cotangent Tangent of x equals cotangent of pi over 2 minus x. Tangent of x equals cotangent of pi over 2 minus x. I should have just written those down.